So one more was with other than water. Here application is heating water at a constant volume. So whenever it is constant volume is told, work done will be zero, but heat transfer will be having some positive value. So here heating of water is taking place. In place of water, they may use some different fluids also, just to make you to understand the different tables for different fluids. Okay. A closed rigid container of volume. See the wordings very important. Read again and again. The container is not moving at all. So you cannot directly take the work done equations. And PV, in PV diagram, V is not changing because it's a rigid container. There is no work done. Zero. By directly reading this sentence only you can tell work done is zero. Closed rigid container. What is the constant volume here? 0.5 meter cube. This is fixed in all cases now. Earlier case we have taken change in volume. Now here volume change is not possible. It is containing some volume, fixed volume, 0.5 meter cube. Is placed on a hot plate. Initially, the container holds a two-phase mixture. See, in the container there are two phases of water, maybe liquid and vapor, or saturated vapor with superheated steam, or maybe saturated liquid with superheated steam. We don't know. It is having two-phase mixture of, now see, this is the condition. What they have given the mixture? Saturated liquid water. Okay, saturated liquid water means it is at 100 degrees centigrade, saturated system. And saturated water vapor, this is also at 100 degrees centigrade. Saturated water vapor means all particles of the water is vapor state or the gaseous state. Any doubts here? Whenever they tell saturated condition at 100 degrees centigrade, when water just starts boiling, so that boiling point we have liquid case as well as water vapor state. Both are at same temperatures, 100 degrees centigrade. So here pressure is also given 1 bar, that is nothing but the atmospheric pressure with a quality of 0.5. So quality is a mixture. In the given mixture, it is having 50% of vapor and 50% of liquid. Both are given. After heating, see now, before heating, the liquid particles are 50%, vapor particles are 50%. After heating, the pressure in the container is P2 1.5 bar. Now because of the closed container, pressure is increasing. If the container was open, if the container is open, what will happen? Pressure will remain constant for long time. What will change? The temperature and other properties will change. But here what they have given? They have given the closed container. Pressure will rise. Yes. Give that also. Okay. Just a minute. Given pressure here. They have given after increasing the pressure up to 1.5 bar heating, indicate the initial and final states. So, okay. After this, they are asking indicate the initial and final states on a TV diagram. TV means temperature and volume. Temperature and volume diagram. On this, we have to draw the sketch and determine the temperature in degree centigrade at states 1 and 2. Now, while finding this temperature, it is very interesting how the temperature is going to increase or decrease or what is going to happen. The mass of the vapor present at states 1 and 2. This we need to find out mass of the vapor present at states 1 and 2 in mixture or without mixture, only in vapor state. How much is in kg? So when it is closed and rigid, we'll see. If heating continues, determine the pressure in bar when the container holds only saturated vapor. 3 cases they have given. Okay. So first you can understand without knowing the theory also. In this book they have given a two-phase liquid vapor mixture of water in a closed system is given. Rigid container is heated on a hot plate. Means to understand with simple words. Initial pressure and the quality and the final pressure are known. So these are the known things given in the problem. What we need to find out? Already I told you what all things we need to find out. We'll see. Next. So one example they have given how you have to understand. Hot plate is there. Closed container, a rigid container is there with fixed volume 0.5 meter cube. So the given values they have mentioned here. Now see the TV diagram. For water, okay, when it is heated, this curve what you are seeing, other than the straight lines, what the curve you can see like a mountain, this is the curve on left hand side. See, if you divide this curve at the tip here, left hand side, whatever the curve you are seeing, it is the saturated liquid water condition. All the particles on this line are water, 100% water. On other side, if you see, another curve is there, okay, like looking like a slope of a mountain. This curve indicates on the TV diagram, it is a saturated vapor state, means all the particles of water are in the vapor state or in the gaseous state after heating. Now question comes, what these points they have given at 1 bar, 1.5 bar, they are heating from 1 bar to 1.5 bar. So while heating 1 to 1.5 bar, what are the changes we are going to observe? Now in between they told x1 is 0.5 bar when pressure is 1 bar. What is x1? X1 is mixture. So this point may be exactly center or somewhere where at point 1 particles are having 50% mixture of liquid, 50% of vapors. So that they have mentioned. At point 2 we need to find out whether all the particles are in vapor or in the liquid state. But point 3 you can see you have to heat up to which condition? They have given the problem only. After heating, so heating will continue. If heating continues, determine the pressure in bar. We don't know. When the container holds only saturated vapor, see the point where they have shown. Exactly at this point, just for reference, I'm telling you, you need not to draw to the scale. But at point 3, it is exactly pointing on the or located on the curve. Okay, saturated vapor curve. So at point 3, X is 1. So quality of the steam is 1 means it is having all the particles of water in the vapor state. This is very important. So 1, 2, 3 processes we need to find out the given questions. So first I'll find out temperatures from state 1 to 2. Next I want to find out the masses. Okay. Now at point 3 we need to find out pressure. Understood the point? Any doubts of understanding the problem? What all things we need to find out? From 1 to 2 I need to find out temperature. From 1 to 2 I want to find out the masses. At point 3 I want to find out final. So this will be higher than 1 bar, correct? So these things we need to keep in mind. Okay. If any doubts, please reply or make a message. Okay, here you can read. Two independent properties are required to fix states. So any state you want to fix, two properties should be there. At initial state, pressure and quality are known. As these are independent, the state is fixed, correct? So point 1 is fixed because of the quality and pressure. Both are mentioned. Temperature is not mentioned. Volume is also not mentioned. So based on that, they have fixed this 1 point. State 1 is as also shown in the TV diagram also. It is in the two phase. Now specific volume at state 1 is found using the given quality and equation number 3.2. So here first we need to find out the specific volumes. Why specific volume is required, I'll tell you later. So using this specific volume per kg basis, I am writing specific volume at V1, small v1 is Vf1 plus x1 into Vg1 minus Vf1. This is the known equation. From first year steam tables, I think you may be knowing, using quality of the steam, okay, and the standard values given in the tables, you can find out these unknown other values. So I want to find out the specific volume first, then I'll find out the temperature. So specific volume at point 1 is given by what is the specific volume present at point 1 when the all water vapors are in all water particles are in liquid condition. Vg means with the quality. How much is the quality? 0.5. They are given in the problem. 0.5 is the quality at point 1. So with first point quality 0.5 into Vg1. What is Vg1? Particles of vapor which are in gaseous form minus particles of vapor, that is specific volume. Okay, specific volume per kg. How much is the specific volume when water particles in liquid state? This equation they have written. So this we need to find out from table A3, or you can go to steam tables and find out what is the given values of Vf1 and Vg1 as a standard value, taking pressure at 1 bar. Okay. So using these values, now I'll go to that A3. Table number A3 in the same book they have told. But while referring, you can refer with the steam table, which we refer in the college. That is because in the exam they will supply the same steam tables. You refer the same steam table with respect to the college which provides in the exams, so that the practice will be easy for you. Now I am referring the same book. Is it visible now? It's taking a lot of time. Okay, once again I'll open here. So from that table at 1 bar pressure or quality of the steam 0.5, at that atmospheric pressure, they have found on 1.0432 into 10 raised to something. Yes. So just read the till it opens. I'll read the values here. 1.0432 into 10 raised to minus 3 meter cube per kg. So whenever you write joules per kg, meter cube per kg becomes specific value. Vg1 in the gaseous form, the volume occupied may be 1 point or specific volume is 1.694 meter cube per kg. Now question comes when the rigid container is given 0.5 meter cube, why these values are changing? Any answers from other students? Why this specific volume is different? Volume for the rigid container is same. Yes, any answer? Specific volume and fixed volume in the container, both are different. If you cannot reply, you can reply in the message also, no issues. But the last pages, they have given tables here. Just as you are referring books, I am referring these same book table only. You can see here, all the pressures, all the values here are at 1 bar. What table they have given? To refer A3. Table A3 we need to refer. So I'm going to this table. A3 table. So in the A3 table, we don't know temperature, okay? But they have told saturated. See the pressure here. Pressure in bar, it should be 1 bar. How much they have taken? 1.04. Here, saturated temperature, I told you 100. 1 bar, nearly 1 bar this here. You see the volume, saturated liquid volume, VF is 1.0435 into 10 raised to 3. 1.0432 into 10 raised to minus. You can interpolate also for the accurate readings. What accurate reading is 1 bar and temperature 100. Exactly at that point you will get the VF1 value. Understanding? 100 temperature. Why 100 temperature? Saturated water. So saturated means it is just boiling from liquid to vapor. So in that condition, okay, liquid particle volume per kg is this much. For the given total mass, it is 0.5 meter cube. But for the given specific volume, only for the liquid particles, 0.5 per part, this is the value, 0.0432 or 1.0435 into 10 raised to 3 meter cube per kg. Next, I'll find out Vg. Vg is directly given 1.673, correct, into 1. So 1.673, just compare here. Vg1 1.694 meter cube per kg. They have taken the values. So once you substitute these values here, you can get the specific volume at 1. After specific volume 1, I'll go to state 2. Pressure is also given 1.5 bar. With this 1.5 bar pressure, what I'll do now? I'll find out the specific volume at 0.2 or directly temperatures. Okay, other properties similar to earlier case, V2 specific volume at 2 also they are finding. There also they are getting 0.8475 meter cube per kg. Okay. So here you need to check whether these values will be same or different. V2 and V1 they are telling both are getting same. For P2 1.5 bar, again referring table A3. See 1.5 bar in that table where they have given 1.433 is there. One more is 1.985 is there. But see the temperature 120. So like this, at saturated condition, you check the values. VF2 is 1.0582. 1.0582 means they have taken 1.5 in between these 2 points, interpolated the values at that temperature and given 1 bar pressure, sorry 1.5 pressure. So 1.5 pressure I am taking this 1.5 pressure in between these two values. So it will be 115 or something temperature. So value is 1.05 something into 10 raised to 3 is the VF1. Similarly here, this value will be 1 point or 0.9 something. So see the values, how they interpolated and taken. So please all of you check today the interpolation technique to find the in-between values. When two other values are known, how to find out by the interpolation method the unknown value. So they have got here Vg2 1.59 meter cube per kg. So comparing this V2 value, V2 is between, okay, what V2 value is 0.8475 meter cube per kg is known value. If you find other Vf and Vg2 from the table, they are getting V2 is less than Vf, sorry, less than Vg, correct? It is less than 1.5. So now I'll come to part A. Reading the table, I'll directly take the temperatures. Now question comes, why directly we are not taking the temperature from the table directly? Why? Because the specific volume is not required to find the temperatures. It is required to find some other values because they are asking the mass and other things. That's why they have started with specific volume. Initial stage only you can write these temperatures. At that point, you can interpolate, and I told you at that temperature it will be 100 or 90. How much they are telling? 99.63 or 100 you can write. T2 temperature here at 1.5 bar pressure in bar here between these 2 points 1.5 whenever you write what is the temperature. So it is 110 plus something. So that if you interpolate you will get 111.4 degrees centigrade around. 5%, 10% error is allowed in the exams, okay? Because always in the calculation, different tables, different experimental methods will give different values in these tables. So values definitely 5 to 10% will vary depending upon the environment and cleanliness what is maintained near the experiments. So temperatures you already know. Now see, finding the mass. To find the mass, we know that total volume is mass into specific volume, correct? In the earlier problem also we have seen that 0.4, how we have taken 0.4 divided by, sorry, 4 by 10 we have taken, that becomes 0.4 kg. So 0.4 kg is the given mass. Before that multiplying given mass, we have taken the internal energy as specific internal energy. Similarly here also, specific volume into mass will give you total volume. On that basis, they are finding the mass here. So for the given mass, they have taken the total mass given for the system is 0.5. Specific volume for the given condition, that is specific volume for state 1, 0.8475. That they have taken and they found out the mass 0.59 kg. So meter cube will get cancelled. In the denominator, it is divided by kg. So finally, we'll get the total mass 0.59 kg of saturated water. Next, you can see the given value of quality. So quality is also was mentioned earlier 0.5. Now what is the vapor mass? So this is I'm telling liquid mass. Now they are finding vapor mass. So in the vapors 0.5% is you have to deduct. Why? Any reason why we need to consider this 50% or 0.5 you have to multiply with liquid? That we are multiplying because in the 0.1, 50% I told you quality of the steam. 50% was liquid, 50% was vapor. So they are multiplying 50% means 0.59 is reduced to 50%. So 59, if you multiply 0.59, if you multiply with 0.5, you will get 0.295 kg in vapors. So these are the vapors, these are the liquid. Now the mass of vapor at state 2, now they are coming to state 2 to find the mass. So in state 2, we need to find out the x. X is not 1 here. X is 1 up at 3. I have explained to you in the problem given. But 0.2 is also containing some part of vapor, some part of liquid at the left side. So to find that mass, okay, if you write the mass, I want quality of the steam into mass or the specific value. To find that, so before that they are finding the x2 value using V equals to or V2 equals to Vg2 minus Vf2 into x2 plus Vf2 as like written in the first problem or the first case. Same equation they are writing for the point 2. So replace all 1 to 2 over. This becomes V2 equals to x2 into Vg2 minus Vf2 plus Vf2. So once you substitute from all the values from the table as explained earlier, you will get, or already you have found out the specific volume V2 0.8475, same volume. You will get the quality of the steam. Now what is the meaning of this 0.731? 0.731 meaning is 73.1% it is containing vapors, remaining 27 part or 27% it is containing liquid. Point is clear? Are you understanding all the steps? Not understanding anything? Please reply. Okay. So from this quality of the steam at stage 2, okay, in stage 2, now I'll find out the mass. So what you can do now? First, I will find out the mass for liquid. If you want to find the mass for liquid, you take total volume by V2, 0.8475. Again, it is 0.59 kg liquid mass. Vapor mass, if you find out, okay, vapor mass, if you want to find out of total volume, 73%, I told you, 73% is what? Gaseous form. So once 73% gaseous form is found out, you multiply that. So out of that total kg, 0.431 kg is how much? Is the vapor state. So all water vapors are measuring 0.431 kg. So all masses we have found out at 0.1, 0.2 in terms of liquid, in terms of total mass, in terms of gaseous mass. Okay, mg1, mg2 we have found out. Next, last point is what? Heating is continued up to state 3 where quality of the steam is 1, or what they are telling, all the particles of water are in the vapor state. At that point, okay, we need to find out the pressure. So again, going to the table at Vg here, Vg 0.8475. So everywhere they are taking V1, V2, V3 constant. See here. Why V1, V2, V3 constant? Because there is no change in volume as mentioned in the problem title itself. Now also you can understand why problem is solved like that. Question is like that. Closed rigid container, no change in volume. Volume is going to remain same 0.5 meter cube. So in the last stage also they have taken the volume of the gas contained or final volume contained in the rigid container is also again 0.8475 meter cube per kg or specific volume. Specific total volume also you can call. This value with this, what pressure they are going to get, you have to check from the table. So go back to table. 0.847 is Vg here. 0.84. See, as you go on decreasing the saturated vapor specific volume, pressure will increase. 0.8 here it is 0.8919, 1.210 or 0.66. In between, 0.84 will come here. Understanding? Between these two values. Between these two values. You have to interpolate and get the pressure. See the pressure. It is between 1.9 and 2.7. So if you interpolate, you will get 2.11 bar. Here, 2.11 bar, near to 1.985 bar. What is the temperature? According to that, it is between around 1.125 or 126 degrees, like that. You can write the temperature also after interpolating. Any doubts? So one more problem they have added here just for understanding. If you want to continue, you can continue with this also. If heating continues at constant specific volume, what is that constant specific volume? 0.84. That Vg, what we have found out, 0.8475 meter cube per kg with the same volume. Again, if you increase the heat above this 0.3, where the pressure is 3 bar, if you continue the heating from 1.5 bar to 2.1 bar, 2.1 to 3 bar, if you continue, determine the temperature at that point. So that temperature is how much they are getting. See the temperature after finding all other values, mass, quality of the steam. Quality of the steam will be 1 now because it is in entirely vapor and superheated steam. So that case it is 282 degrees centigrade. See the temperature now, it is above 100, also 111, correct? So above these all temperatures it is crossing. This becomes the continuation of the different processes. Okay, any doubts till here? Okay. Next, I'll consider the second law of thermodynamics, that is given by Kelvin's Planck statement or Clausius statements. Both statements tell that it is never possible to convert all heat energy from the reservoir using an engine into all the heat into work. So 100% conversion of work into heat is not possible by one statement. Another statement is also same thing. When the heat is transferring from lower temperature sink to the higher temperature reservoir, okay, so work cannot be zero. So there should be some work required when you transfer the heat from low temperature to high temperature. The examples given are, one is heat engine, other is the heat pump, heating the or transferring the heat or energy from low temperature to high temperature, or also they have given the name as pumping the heat from lower to higher region. So that is not also possible without any work done on the system. So taking those two cases, here a problem is solved. A power cycle operating between two thermal reservoirs. So one is the reservoir, one is sink, receives energy QH. Okay, receiving means it is transferring from reservoir to some machine by heat transfer from a hot reservoir at temperature 2000 Kelvin and rejects energy QC. So rejection of heat they have mentioned as QC here in this problem, by heat transfer to a cold reservoir. So to the cold reservoir, or we many times tell it as sink. So temperature is 400 Kelvin. So between these reservoirs 2000 and 400 Kelvins, the heat is transferring between a machine. For each of the following cases, determine whether the cycle operates reversibly. So whether the cycle operation reversibly is possible or not, or it operates on irreversibly, or it is an impossible cycle. So three cases you have to check with all these three given conditions. First condition is amount of heat transferred is 1000 kilojoules. So when heat is transferring from higher to lower temperature means definitely we recall a heat engine here. And efficiency of that engine is 60%. Heat engine efficiency is 60%. Second case they have given same heat transfer. See all the three cases heat transfer is same 1000 kilojoules. See the cases. One more heat engine where work done by the heat engine is 850 kilojoules. In that case, the cycle is reversible or irreversible or impossible. Last case, heat transferred for both reservoir as well as sink, they have given 1000 and 200 kilojoules. If this is the case, what is the condition? Whether the cycle is reversible, irreversible, impossible. I will not read it again given and finding cases. You can draw this example. So many times in the class also you might have seen these examples, sink and reservoir, between which we have fixed one machine here. Or you can take example of heat engine. So directly coming to the solutions, just you have to comment the results after finding some values. So first case they have given the efficiency 60%. So I'll write the efficiency of the heat engine by using second law of thermodynamics or this diagram. So don't keep in mind that efficiency of any cycle is same thing. It depends on the given problem. Here in the problem they have given only temperatures. From the second law, I'm writing this equation for the heat engine. If it is a auto or diesel cycle or a Brayton cycle or a refrigeration system, then in that case, efficiency or COP equations will be different. So don't get any assumption that equation will remain same for all the cases. So that is given by TH minus TC by TH. After simplification, they have written 1 minus, because TH by TH is 1, minus TC by TH will remain as it is. So using that, they have taken 1 minus. So anytime if you are taking ratios, no need to convert the temperature into Kelvin or degree centigrade, or no need to convert any units when you take the ratios. So they have taken the ratio here 1 minus 400 by 2000 as it is. So efficiency is 80%. See the first case. So efficiency of the engine was 60%, but we are getting 80%. What is the answer you have to write? Efficiency of the given system is less than the maximum, so cycle operates irreversibly. Cycle. When it is reversible? Any idea? Yes. Okay, we'll see the cases. Second case you can see heat transfer same. Now they have given the work done. So work done equation with respect to heat transfer, we can write efficiency is given by also work done by the system or the cycle divided by heat transfer. So they have given work done 850 and 1000, both are in same units. Ratio we are taking, no need to convert. So again 85%. So 85% is what is going to happen? This efficiency is more than the given efficiency of the cycle. Correct? So this or the power cycle is impossible. How they are deciding? It is impossible or irreversible? Any idea? The power cycle is an impossible cycle. Does anyone want to reply? Okay, last case they have given. What is the last case? Last case they have given both the heat transfers. And now we need to find out the whether the cycle is reversible, irreversible or impossible. So for part C, using these two heat transfers, I can find out the work done. See here, work done by the cycle is QH minus QC. That much of work done. Ideally, we find out that. Actually, there is some losses. That's why we call about the efficiency. Now see, how much heat transfer is possible? Only 1000 and 200. 800 is possible in the given system. That's why after you solve all three cases, then you comment the results. Don't comment the results before solving any problem. Now see, the maximum heat transfer possible in the given cycle is 800 kilojoules. Next, they will find out the efficiency. So efficiency using work done. How much work is possible in third case? 800 divided by 1000, 80%. Okay. So using all these values now, so possibility is 800 kilojoules. According to that, you are getting 80% is the maximum efficiency. Using this 80%, cycle operates reverse. You can reverse it. So if you add work for heat pump, if you add the work here to the system, 800 kilojoules, then what happens? Heat will transfer from lower temperature to higher temperature. It works as a heat pump or a refrigeration system. So it is possible or reversible. Impossible means, see here, you are crossing more than 80%. Impossible, because if you calculate all the values, you'll come to know 80% is the maximum possibility as per the cycle work done. Now see here, another case. Another case is what? They have given 60%, but maximum possible is 80. So what is happening here? 60 means it is irreversible. You cannot reverse it. If you reverse it, efficiency may be 20 or 20% for heat pump or 80% for engine. That is not possible here. It's working with the lower efficiency. You cannot irreversible it. So these comments you have to write after completing the problem. One more case they have given as a quiz. If heat transferred to the sink from the heat engine is 300 kilojoules and work done by the cycle is 2700 kilojoules. Okay, if they change these values QC and QH, if they change the values, determine whether the power cycle operates reversible, operates irreversible or impossible. So you can find out the QH value first. After finding QH value, you find out the efficiency. As like above cases, you use the equations. Once you find out QH and efficiency, you can comment the result. Okay, so answer is becoming impossible. Why it is impossible? Because efficiency may be increasing, or maybe the heat transfers or the energy transfer may be more than or less than 800 kilojoules. So in that case, it is impossible cycle. Clear? So this is the 5.1. You can also see some examples, 5.2 and 5.3. Same type of procedures and other things, but the cycle is different. It is moving from cold to hot region. Earlier I took hot to cold region. These are the changes you need